Hello, this is the course of data mining, and in this section, I would like to discuss about classification. So I would like to discuss about maybe this is not all the discussion. So I will like to discuss this part. Okay, what is classification, and then what is prediction, and some issues regarding classification and prediction. And we are going to learn about the classification by decision tree induction. Okay. So there are many other classification like Bayesian and rule based, but I do not want to discuss that one. So I will just focus on this one. So at the end, we will learn some basic performance metrics for the classification. I took this material from the Jia Wei Han, Marceline Camber, and Jian Pei too. So first, we need to understand what is the difference between classification and prediction. In many domains, we have idea classification. In the word classification, it means we want to classify. Classify means we want to predict the categorical class labels. So here, for example, we have the categorical target, or we have the categorical class label. You know what is categorical? Yeah, it is discrete, or it is nominal data. The decision whether you want to buy computer or not. If no, it means you do not buy a computer. If yes, it means you buy a computer. So there are some attributes here, for example, age, income, student, and credit rating. If the age is less than 30 and if the income is high, if he is not a student, if the credit rating is fair, then he does not buy a computer. Okay, so this kind of data are available, and you can try to figure out to do the classification. So in this case, we can classify the data, or we can say we construct a model based on the training set. Okay, so what is training set? Yeah, we will check later. And the values or the class label in classifying attribute and use it in classifying new data. So let's say if I have this data, and let's say I put this one, data here until here is the training, and the data here until here is the testing. Okay, then yeah, we usually do that one to verify the model with the training and the testing data. Okay. So the prediction. Okay. What is prediction? So based on this definition, okay, we want to model the continuous valued function. So model the continuous valued function. That is, we can predict unknown or missing values. So here, most of the data are categorical. Okay. So when we are doing the prediction, actually we are dealing with the continuous values. Okay. And yeah, we can predict the unknown or missing values. Yeah, if there are some missing values here, we want to predict. Okay. In sometimes, yeah, we can also say that if the class label is the continuous value, then we can also say it is about prediction. What will be the next result? So we want to say it is also prediction. Okay. And the typical application is about the credit approval, whether you can approve a credit request or not. Target marketing, so you will see if you target youngers, whether they want to buy the product or not. Medical diagnosis, so if you get this medicine, whether you can be cured or not. Fraud detection, whether it is false or true transaction. Okay, so those kind of things can be in the classification, and depending on the data, whether it is a continuous value or categorical values. There are two-step process for classification. The first is to make the model. Okay, so to make the model means we can describe a set of predetermined classes. Okay, and each tuple or sample is assumed to belong to a predefined class as determined by the class label attribute. Okay, so maybe we will see a example later. And the set of tuples used for the model construction is training set. Okay, we call it the training set. And the model is represented as the classification rules or decision trees or mathematical formula. So after we construct the model, we can use the model or model usage. So the model usage is for classifying the future or unknown objects. It means if we have the accuracy, okay, if we know the model, then we can estimate the accuracy of the model. And the known label of the test sample is compared with the classifier result of the model. So we have what we call as the known label on the test sample. We want to classify from the model. So we will see this one more later, okay? And we will have this accuracy rate. So this accuracy rate is the percentage of test set sample that are correctly classified by the model. So we will always think this one, okay, accuracy rate. And the test set is independent and the training set. And yeah, we need to avoid like this overfitting. Okay. So if the accuracy is acceptable, then yeah, we can use the model to classify data table tuples whose class label are not known. Okay, so at this you will know that we will need the model construction and model usage. So we will see more details later. So I have example like this. It is a kind of classification problem. I have a collection of annotated data. So I have 1, 2, 3, 4, no, only 5. Well, sorry, we have 7 instances. 8, 1, 2, 3, 4, 5, 6. Okay, no, this is only example. Okay, and I have this figures, and it belongs to catarrhs. And I have these figures, and it belongs to grasshoppers. Now I have one picture here, and I have no label. Can you decide? Is it catarrh or grasshopper? Okay. It seems difficult, right, to determine whether it is grasshopper or catarrh. So we can do something by finding the features. You know already, we have features, we have dimension, we have attributes. Okay. So for any domain of interest, we can measure the features. Let's say I know this is the insect, and I can define the features like the color. So green, brown, gray, maybe other. Okay. And I have also the information about the thorax length. Okay, the thorax length is this one. This is the thorax. Or I have the abdomen length. Okay, this is the abdomen. Or I want to measure the spherical diameter. Or I have the leg length. Okay? Or I have the mandible size. Or I have the antenna length. Okay? Or whether the insect has wings or not. So you can extract all those features, and let's say I would like to have maybe I only have these two, abdomen length and the antenna length. Let's see only from those two features. Yeah, but for this is the simple example. You can create a better example if you have. Okay, now I collect this data. Okay, so we have this training data. Okay, and this is the training data. Okay, and then yeah, we have this 2.7 abdomen length and the antenna length is 5.5. Okay, this is grasshopper. I have the abdomen length 8 and the antenna length is 9.1. Okay, it is cathodic. I have another data 0.9 and I have the antenna length is 4.7. Okay, it is grasshopper and so on. So we have 10 data. Okay. Usually we have the testing data. Okay. We have the testing data without this one. Okay. But you, in order to make a good model, you need to provide also the class information so you can compare. If we already learn from this data, can we predict on this data? Okay. So after we have this abdomen length and we have the antenna length, okay, we do the model construction. So we do the model construction with the training data from the data collection. We have 10 data and we create the algorithm. After we create with the classification algorithm, we can make a model. Okay. And once we have the model, then you can, yeah, let's say I have the model. Okay, so the model is based on the decision tree, maybe. So after I plot with this visualization, okay, I have this abdomen length and then I have this antenna length. Okay. Oh, this is interesting. If the abdomen length is low and the antenna length is also small, oh, it shows it is grasshopper. If this antenna length and if the abdomen length is big, it seems to be candidates. Okay. Now it's clear until now that you can have a kind of separator like this one. So the higher is candidates and the lower is grasshopper. Okay. So we can call this is simple linear model. Okay. Now if I have my data like this one, so I can see this is the model. Okay, I just use the simple linear model and then let's suppose I have the testing data. So this testing data here, I have 5 additional data and yeah, I have this insect. Okay, and based on this data, I would like to know which data is this belong to. Is it really grasshopper or not based on this linear model? Okay. So if I check, okay, everything, yeah, grasshopper is here. Okay, this is correct. Candidates, this one, okay, this is correct. What about this? Okay, this is correct. How about this? This is correct. What about it? Okay, this is correct. Then everything in the testing data, whenever we fit into this simple linear model, it shows that 100% it fits. Okay, then the model is very good. Okay, now if I have something that I never see before, what do you expect about this one? Now let's see. 5.1. So 5.1 abdomen length and antenna length 7.0. 7.0. So it will be something around here. Okay. Now, what is the possibility of this insect? Yep. Grasshopper? Oh, really? No. Candidates, are you sure? Yeah, because our testing show that this model is good. So we can say that this model can classify the previously unseen instance into candidates. So without knowing the details, yeah, if I know the abdomen length and if I know the antenna length, then I can say that this insect is candidates. Okay. So yeah, I can explain to you about what is supervised learning. Okay, I got this one from Professor Sok. He explained the maybe you have difficulties to understand English, so I keep this Korean for you to understand about the supervised learning. So in Korean it is Jido Haksup. Yeah. So we have the information about the label, or we have the information about the output. Okay? And we want to let the algorithm to learn from the input, so we can predict the output. Okay? If we know the output and we know the input, then we can try to make the algorithm to work, to understand what will be the output based on the input. We can have like spam. So the input, it could be the email, and then you can have like what are the emails that categorize into spam. Okay? And then the training algorithm will check whether the email is a spam or not. It is about the classification. So if it is unsupervised learning, we do not have the output. Okay? We do not have the output. So we just have the information about the features. Okay. So this is the explanation in Korean. So let me explain a little bit in English. So when you have the supervised learning, okay, we call the classification. Yeah, there are many other supervised learning, but I will teach you about the classification. It is a supervision. It means the training data, or we have the observation, or we have the measurements are accompanied by labels, and the labels indicate the class of the observation. So we have this class. Maybe you will know only the abdomen length, you know the antenna length, but yeah, without the class, then you will not know anything, because we have this class, so we can make the learning algorithm to understand. Okay. So new data is classified based on the training set. What about the unsupervised learning? Okay. The unsupervised learning, now it is related with the method clustering. Okay. We don't have the class label, so we only have this data. But at the end, what will you classify? Okay. So given a set of measurement of or observation and etc., with the aim of establishing the existence of classes or clusters in the data. So the result of this one, it might be like we have this one. Okay, this one belongs to cluster 1. What about next? Oh, maybe this one belongs to cluster 2. What about next? It belongs to cluster 1 because the data is similar. What about next? It is also belongs to cluster 1 because it's similar. What about next? Maybe this one belongs to cluster 2 because they are similar with cluster 2. This one cluster 1 and this one cluster 2, for example, and so on. Okay, so we can measure the distance. We can measure the similarity. And because we know the distance, we know the similarity, then we can just mention this as the cluster. And once we know the cluster, maybe we can put, or we can check according to this kind of class name. So when we are dealing with this kind of classification, of course, this is very important to have a clean data. The data cleaning is very important, because if your data contains some noise, or if your data contains missing value, then you cannot do the analysis. You cannot perform the classification. And the other thing is you need to understand the relevance analysis. So a good feature is necessary to do the classification. It means we need to remove the irrelevant or redundant attributes. Data transformation. This is also important. If your data is good, yeah, you can easily do the analysis. But if your data is not that good in terms of the statistics, because there are many, maybe the gap between the maximum and the minimum is very high, so you need to maybe generalize or normalize the data. So this kind of issue happens before you do the analysis, or before you do the classification. And later, when we are doing with the classification, we need to measure the accuracy. The accuracy means, yeah, we can have the classifier accuracy. How well is your algorithm to predict class level? And we can have also predictor accuracy, guessing values of the predicted attributes. So if you are dealing with the numerical or the continuous value attributes, then we want to predict. And if we have the classifier, then we want to classify. And also we need to consider the speed. It depends on the time to construct the model, whether the training time, or time to use the model. It is the classification time or the prediction time. Robustness is also another issue when you do with the classification. For example, how robust you to handle the noise, and how you handle the missing values. Because if you include the noise, the accuracy will be low. If you include some missing values, or if you handle the missing values and you include, you change the missing value with the mean, then it means maybe mean is not good, because there are some bias. You need to use median, or you cannot use mean, you cannot use median. Maybe you need to use the standard deviation. So you need to check whether those one of these methods can be robust for your model. And also the scalability, whether it is efficient in the database or not. Because when you do with the modeling, if you do with very complex model like deep learning or other kind of complex model, it's not efficient. Interpretability, it means we want to understand and have a good insight provided by the model, whether you can understand it. So if the model is too complex, that's why when we have the deep learning, usually we say this is a kind of black box. So if it is a black box, you cannot understand easily, you cannot interpret. And also there will be some other kind of measures. For example, goodness of rules. So for example, the decision tree size is important. If you have like the decision tree, and the size, maybe the size is too deep. So if they are too deep, it will be so complicated. It's not easy to understand. But the compactness of the classification rules. So if it is compact, maybe it is good, but maybe it will not generalize the idea. So those things, yeah, will be very important when you are doing with the classification. Okay, so I guess until now you can understand what is the difference between classification and prediction. Yeah. So in classification, we are making the classify, or we want to predict, we want to handle with the categorical class label. Okay. When we deal with the prediction, it means we are dealing with the continuous value. Mention the two-step of classification process. So we have the model construction and we have the model usage. Okay. What is the difference between the supervised and unsupervised learning? So if it is supervised, then you already have the output. Okay. The output means the class label. Okay. But the unsupervised, you don't have the output. You don't have the class labels. So you need to measure the similarity, or you need to measure the distance in order to find out whether the data is similar or not, whether they are in the same group or not. Okay. What are the issues in the data preparation? Okay, the data cleaning. Okay. And then the data, the feature selection and data transformation is the issue in the data preparation. And what are the issues in the evaluation classification methods? So those are the issues like accuracy, speed, robustness, scalability, interpretability, and other measures. Okay. So yeah, we are going to learn about the algorithm. Okay. And the basic algorithm for this decision tree, it is based on the categorical data. Okay. That's why we call this is classification. Okay. You can see the age is categorical, income is categorical, student is categorical, credit rating is categorical, and this label is also categorical. This follows an example of Queensland ID tree, buying computer. ID tree is induction decision tree, okay, or decision tree induction. Decision tree induction. So the decision tree, the result is something like this one. Okay, when we learn and we can get like the question, what is the age? Okay, the age is less than 30. Okay, then we will ask again, is he a student or not? If he is a student, oh yeah, he buy computer. But if he is not student, the decision will be no. If the person is in between 31 until 40, oh, everyone buy the computer. What about if the age is greater than 40? It depends on the credit rating. Okay, if the credit rating is excellent, no, the person do not want to buy. But if the credit rating is fair, oh yeah, he or she will buy. So this kind of decision tree is based on this data. Okay, for example, if you check on the previous this one, it's 31 until 40. Okay, what happened? 31 until 40. Yeah. Okay, the decision is yes. 31 until 40. Oh, the decision is yes. 31 until 40, 31 until 40, and the decision is yes. Okay, then all person who are in the age 31 until 40, he or she will buy computer. Okay, so this is based on the data. then yeah, I can just give you an insight about the basic algorithm. The algorithm for the decision tree induction is a kind of greedy. Okay, greedy means you will check all the possibility. So the tree is constructed top-down, recursive, divide and conquer manner. So you will go from the top and then go to the bottom. Okay, and at the start, all the training examples are at the root. Okay, so you will start from the root, and attributes are categorical. Okay. So if it is a continuous value, then you need to make it as a discrete. So we will learn examples. Examples are partitioned recursively based on the selected attributes, and the test attributes are selected on the basis of a heuristic or statistical method. Okay. So this is the basic algorithm for the greedy algorithm, and there will be condition for stopping partitioning, because if you don't have the condition, then the result will be like iterative, and it will go in more and more complex. Okay, sometimes you need to have the condition for stopping criteria. For example, if all samples for a given node belong to the same class, and if there are no remaining attributes for further partitioning, so it means the majority voting is employed for classifying the leaf, or there are no sample left for checking. Okay. So the concept of ID tree, or the algorithm C 4.5, okay, it is based on the highest information key. So let's say if we have the P, okay, Pi is the probability that an arbitrary tuple in D belongs to the class C, and we can estimate with the number of C divided by the number of D, and the I is in between 1 until n. So it is based on the entropy value. Okay, so the entropy is based on the expected information value. We can use this information. So it is from the information gain. Okay, if it is pi multiplied by log base 2 pi, and then we will do the summation from I equals 1 until n. And then we will do with the information needed to understand the, after we use the A to split D into V partition, then we will do this, we will do this calculation, and finally we will get the information gain in order to check whether it is a gain or not to keep that attribute. Yeah. So I would like to explain about the entropy. Okay, what is the meaning by entropy? Yeah, I also took this one from Professor Sok about the explanation in Korean. Yeah, I already asked his permission to use this one, and yeah, I think it's better to see from this entropy examples. When we use these entropy examples, the information gain, okay, you can use this formula, and we can have the high entropy and low entropy. So this entropy, it can be, say, something like the energy, or yeah, if the entropy is something like always giving you more information. Okay, if you can get more information, then yeah, you can easily split, or you can easily distinguish the data, or you can easily distinguish the information into something useful. So for example, okay, for example, if the coins, okay, you know coins, I want to flip the coins. So whenever I split, whenever I flip the coins, yeah, if yeah, case 1 is front and the case 2 is rear. Front means appe bubun, rear duinan bubun. Okay, For example, if I always toss the coin and then for 10 times, okay, for 10 times, I always get front, 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 and then I toss again another 5, front, front, and front, front, and front. Oh, so every time I toss the coin and I got front, what happened? Yeah, we know that the coins, there are two, front and rear. So when we calculate with this formula, when we calculate with this formula, then I can get the probability. What is the probability? The probability of front is 1, okay, because among the 10, we have 10. So 10 divided by 10, yeah, is 1. And then log base 1 is also 1. Then 1 multiplied by log base 1, and the result is 0. Okay. But what about if I have like F and then R, rear, okay, and then rear and F and then F, and then rear and then F and then rear and then F and then rear. Okay, so from this data, you can see that, okay, we have 1, 2, 3, 4, 5. Okay, there are 5 data among 10, which is front. So yeah, we can say half. And rear, 1, 2, 3, 4, 5. So we have also half for front and half for rear. Then we can fit into this formula. So half, okay, minus half, okay, minus half, log base half, minus half, log base 2 half. So the result is 1. Okay, when you can check with the log function later. So because it is 1, then it is easy for me to say that, okay, it is more informative. It is more information, okay, because I can distinguish the front and the rear. But here I cannot distinguish the rear because the data is only front. Okay. The other example, if okay, now we have 2 coins, whatever. If we have 2 coins, though, it will be more complex actually. If the first coin is front and the second coin is front, or if the first coin is front and the second coin is rear, or if the first coin is rear and the second coin is front, or if both of the coins are rear. Okay, let's suppose like this one. Among the experiment, we can get this one. 1/4, 1/4, 1/4, and 1/4. When we fit into this entropy with this formula, okay, the result is entropy is 2. Okay? So if we have a very similar value on the probability, yeah, the entropy value is high, and we can distinguish the class 1, class 2, class 3, class 4 easily. But what about this? 1/8, 1/8, 2/8, and 4/8. So this is not equal on the probability. What happened? Yeah, this is more distinguishable. Okay, why? Okay, maybe the class is more on this one, okay, rather than the other class. So this will get more information. I can get more information on this class number 4. Okay. Oh, sorry, maybe it's not more than this one. Okay. This one is more and this one is less. Okay, but if you have this one, yeah, you cannot get more information because the information is only on this one, and the other is 0, 0, 0. We have no information about the class A, class B, and class C. So this entropy is 0. So which one is the best one? Yeah, according to this, yeah, it will be better if we can have the high entropy value, because the high entropy value we can easily distinguish. Okay. Now I would like to explain about this information gain. Okay. And this is yeah, we will try to calculate one by one. For this example, let's say the P or the positive is computer yes, okay, this yes, 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 okay. And then no is the class N, okay. So this is no, and no, no, and no. Okay, from this examples we can check actually. We want to measure the expected info when H is unknown. So I want to just measure the number of P and the number of N. Okay. So here number of P. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So there are 9 of positive. What about N? No. So we have 1, 2, 3, 4, 5. We have 5. So the total we have 14. Okay. And according to this value, we can measure the info D. Okay. What is the info D? We can use the function that we have before here. Okay. So this is the value we have, the probability. The probability is the Pi with the positive and Pi for the negative. So here 9 divided by 14 means 9 divided by 14 of 14 is the overall data, multiplied by log base 2, 9 divided by 14, and then minus 5 14 log base 2, 5 14, and the result is 0.94. Okay, this is the information when we have the 9,5. Okay, 9,5. Now, when you go to the next, you will do one by one. Okay? You will do first by age, and then you will check the information, and then after that you will do with income, and then you will check with the student and so on. So let's say I'm doing with the age. Okay. Now you can check if the age, yeah, we have the age is less than 30. 31 until 40 and greater than 40. Pi and I, it is the positive and this is the negative. Now let's see if it is the positive. We know that, yeah, greater than 30, yeah, greater than 30, greater than 30, greater than 30. How many yes do we have? This is no, no, no. Okay, so there are 3 no and there are 2 yes. Okay, 2 yes. So the total is 5. So we have 5 data for less than 30. What about the 31 until 40? 31 under 40, yes. 31 under 40 is yes. Okay. 31 under 40, 31 under 40, yes. Okay. Then we have 4 data and all 4 are positive. What about greater than 40? Okay, we have greater than 40. So we have yes, yes, no. So we have yes. Okay, then we have 3 yes and we have 2 no. So the total is 5. Okay. Then after we have this table, we can go to the next, okay, and calculate this information gain. Okay. So now we have the information about the age. So this is from the previous table. Okay. And if age is less than 30, what happened? We can measure with I 2,3. So 2 positive and 3 negative. Okay, 2 positive and 3 negative. Then we can fit into this formula, minus log 3 divided by 5 log 2 5. So we can get this information gain with the h is less than 30 is 0.97. If h is between 31 and 40, then it is 0. Okay, because if 1 is 0, then it is 0. If it is greater than 40, then yeah, we can also have the same formula like this one, and the result is 0.97. Now we can measure the overall about the information of TH. What is the overall information? Okay, the overall information is, we know that the total here is 5, and the total here is 4, and the total here is 5. Okay, so 5 divided by 14 multiplied by I23. So this is from here, and then we have 4 among 14, and the information gain is here. Okay, 0 multiplied by any value will be 0, and then 5 divided by 14, this is from here, multiplied by I 3.2. So this is 0.97, and we can get the result 0.694 for the information in the column 8. Okay. So what is the gain 8 then? The gain 8 means I would like to see the overall information gain and minus by the information from the H. So this is the information from H. And what is the result? Okay. So we got the information when we have the all values equals to 0.940. So we have 9 positive and we have 5 negative. Okay, and the result is 0.940. And yeah, we have this 0.94 minus 0.694. So the result will be 0.246. Okay. Now, after we have this value 0.246, so this is the information only for the gain in the attribute H. What about the attribute income? Okay, you need to measure the same way with the attribute H. What about the gain of the student? So you need to measure based on the student. What about the gain on the credit rating? Okay, you need to measure again based on the credit rating. So we get this value for H. You get this value for income. We get the value for student, and we got this value for the credit rating. Which one we can choose? We need to choose the highest information gain. So the highest information gain is here, 0.264. The highest information gain means the most discriminating power with regard to this target attribute. So we can say that H is the highest information gain, and this is the root. Okay, so the root means, the root means the highest information gain or the most discriminating power with regard to the target attribute. Okay, yeah, I think I will stop here, and yeah, we will continue again the class in the next class. Thank you very much for listening.